Hi, good morning everyone. In this video, we will explore one of the most useful features of MolSoft interface, integrated database searching. MolSoft provides seamless access to several biological and chemical databases, allowing you to retrieve the relevant information without leaving the software. So this integration seamlessly, streamlines your workflow by enabling quick access to structural, sequence, and chemical databases as well. So the databases available within the MolSoft include PDB database, you can do PDB and NCBI BLAST for template search during homology modeling. UniProt is also been integrated into it. You can also do PDB by sequence pattern search. You can do a search by PDB sequence match, homologs, PubChem, ChEMBL, crystallography open database, drug central and other databases as well. So let's begin by exploring how to search the protein data bank. From the database search panel, select PDB and let's try if at all I want to search with a name of a class of a protein. For example, let's me type kinase and enter. So it hardly takes few seconds, and with this particular key term, like we kept it in all fields, kinase. So wherever it is being tagged with a kinase, it retrieves all the PDB information that is there, all the information of the PDBs which are tagged with this kinase. Again, similarly, if at all I'm interested in typing and searching data with a specific protein, let's assume PARP1. And if I do a hit on this run search, or I can enter it as well here. Now, quickly you can see it has retrieved me all the content with regards to the PDB here. And I can search this data by one single click, sort it from based on the ID. I can sort it based on experimental methodology, resolution, and every single tab available here. For example, now as you see, I have typed only the name of the protein, PARP1, and if at all, it retrieved me all the data irrelevant to experimental methodology and irrespective of the source. So let me see what are all the different experimental methodologies I have retrieved. To know that, I'll just, if at all I'm interested in only looking into one of the methodologies, like I can give a right click, filter, and from list, and you'll see I just typed the name of the protein. It got me all the structures which were resolved using electron microscopy NMR, and I'm interested more into a X-ray structure. And I'll select this, check it, and say apply, and say okay. Now whatever the structures you are seeing here are only the X-ray structures. Similarly with the source, I can give a right click, put up a similar filter from list, and I'm interested only the ones with the Homo sapiens. So if I say apply and say now whatever the content we are seeing here is only based on the humans and the PARP X-ray structure. Now, last but not the least, even you can see the structure, the 2D structure of the small molecule with it is co-crystallized. I can move these fields from last to first and first to last. Now you can see, if at all I wanted to load this, I can just give a double click and load it into the GUI here. Even you can see a small sketching button available here. When I hit on this, it opens me a chemical editor where I can do a substructure search of the ligand which is there in the PDB. So this is a quinazoline ring, methyl substituted quinazoline. If I just save this, now you can see the smiles being displayed here, and I'm trying to hit on this binocular button, and you see it displayed all the results here below with the substructure, the quinazoline, methyl substituted quinazoline. Now you can see it does a substructure search very quickly, and you see the last hit being such a big molecule, this being a protag, and you can see the substructure of this is again a quinazoline methyl substituted. So this is how quickly you can explore this search, and even we can again extend this to, for example, so you can see now just quickly I can retrieve all the X-ray structures, all the structures that are there that are uh, co-crystallize with this drug called ibrutinib, which is a covalent inhibitor as well. And further, I can even extend this searching to some other things as well. I can also search with regards to the ligand code 3JD here. You can see. So now this 3JD, this is a molecule with which all these crystal structures are available. And I can even search with another option like experimental method. I can type here NMR and I can retrieve all the NMR structures that are deposited in the PDB. So this is how these are the few. I can even search with the author name. I can type the name of the author here and I can do a search which will retrieve all the PDBs or all the structures which were resolved by the author named Zhang. So this is how we can explore all the features from the PDB search. Now let's do a search in the PubChem. For example, there is a sketching button here. I can do it multiple ways. Even I can type directly the name of the drug here. For example, ibrutinib and enter. So this quickly goes to the PubChem and it fetches the data, the structure and the activity and the CID of this ibrutinib. Right. If I click on this, so it will fetch all the data with regards to this, to whatever the targets you can see. This is the activity ID, the target particular gene ID, and the activity name, and if it is on which it has been assayed, and the log uh, of the IC50 values, the log activity values, and the assay type and the format ID associated with it. And again, this is the CID, this is the compound ID. If you can click it and it takes you to the PubChem web page where this is the ID, exact ID can be here. So this is with related to one thing, one particular molecule. For example, if I want to fetch a list of compounds from here, I can type the ID, multiple IDs, the CIDs here, a space between each ID and hit on the binocular button to retrieve these three compounds. So this way I can retrieve the multiple CIDs if I wanted to retrieve them. And again, you can also do a substructure search as well here. You can click on this sketching button, go here and sketch the molecule of the substructure of your interest. And so this way I can sketch it, save it, and do a search here. And if you check on this, it will import the 3D structures of the 3D molecules, the structures of the molecules in 3D. And if you want to append, so the new data table will not be generated, it will be added to this particular table. And at the max, we can retrieve, here it is 500. It is up to the user, he can increase or decrease the number of hits he wanted. So we can again hit on this button. So this search, it does. This is how the user can do a search in NCBI BLAST. For example, I can put the sequence or the protein pattern here. So here I will write CHK2 underscore human, and I'm going to search it in either in UniProt or the sequences in PDB or all non-redundant data. So it is again up to the user to select this. So I can select this and I can run the job in the background and say search. It takes quite some time to get all the data. You can see after completing the job, you get this kind of pop-up saying OK. So this will load the results in the GUI, and this is all the data. The user can get the data, and gives you the length of this PDB with which it is matching the sequence, right? The length of this protein and the accession number and the score, e-value, the identity, and the similarity and rest all other data also the user can get. So this is all about how the user can search in the NCBI BLAST. This is the ChEMBL search where the user can type the name of the protein PARP1, and here specifically let's select target and do a search, quick search. So it gives this kind of data table where this is the name, the ChEMBL ID of this PRP1 human and other organisms as well. You can see this table, which again consists of the ChEMBL ID and the name of this protein and the target protein, target type, and the UniProt ID, how the way it is mentioned, and the number of compounds. If I want to retrieve these molecules, I can quickly check this ID and then get activities for check targets. So once I click on this, I get this kind of data table where you can see it has the structure of the molecule, chemical compound, and the molecule name, and the activity ID, and the UniProt ID, target name. So you can see a number of, and the UniProt accession number as well, and the activity is less than or standard values, and the
units, right? So this is all the data what you get. Here again you can see activity ID, right? Assay ID, ChEMBL ID, and you have this molecule ID, you have this parent molecule ID, target organism. So all this data can be retrieved, and in this particular molecule, in which particular journal it has been published. So this is the PubMed ID. So this all the data can be viewed, and the user can again specifically select the molecule and type the, if you have this particular molecule ID, ChEMBL ID, you can type this ChEMBL so and so ID here, and you can get the information as well. And similarly, you can do, always the user can do a substructure search as well here.